Hi everyone, in this video we'll take some applications on the tangent line. So we have three parts, A, B, and C. In part A, find an equation of the tangent line to the graph of y equals f of x at x equals to -3 if f of -3 is 2 and f prime of -3 is 5. So to find the equation, always you have to get a point. This is step 1. You have to find the slope, and as you know, the slope is f prime at x node, and then you have to find the equation of the tangent line. So everything is given for you, because first you have f of -3 equals 2, which means the point -3 and 2. So this is x0 and y0. Then we have f prime of -3 equals to 5, and this means that the slope equals to 5. So m equals to 5. Just you have to do is to write the equation of the tangent line and plug in the value of m and the point. So y minus y0 equals m multiplied by x minus x0. Here we have y minus y0, which is 2, equals the slope m, 5 multiplied by x minus -3, which is x plus 3. So what we have now, we have y minus 2 equals, you have to multiply 5 by the parentheses here, and you'll get 5x plus 15. Then you have to add 2 to both sides, or move -2 to the right hand side and change the sign of -2, and you will get the equation of the tangent line. So we have y equals 5x plus 15 plus 2, which is 17. Now in part B, find k if the curve y equals x squared plus k is tangent to the line y equals 2x. Here we have another issue, and this is a quadratic equation. This is a quadratic function, y equals x squared plus k. It is like the graph of x squared, but you have to shift the graph k units. So it will be like this. Here is the function, y equals x squared plus k, and this is the tangent line, y equals 2x. And you have to find k, for which y equals 2x is the tangent line. You have to find k at which y equals 2x is a tangent line for the given curve. Now this is the tangency point, and we don't know what's the coordinate of this point. So let's say it is x0, y0. Since x0, y0 is the tangency point, this means the slope of the curve at this point is the same as the slope of the tangent line at this curve. So the slope of the curve is y prime. So we have y prime equals to x. And the slope from the equation, y equals to x, is 2. So these quantities are equal. So we have 2x equals 2, and divide both sides by 2, you will get x equals to 1. So this is the x coordinate for the point of tangency, x equals 1. Now how to use it to find the value of k? Again, since the tangency point is common between the curve and the tangent line, this means if you plug in x and the curve, it will be the same as the plug-in in the equation of the tangent line. So this is our curve, y equal x squared plus k, and if you plug in x equals 1, you will get y equals 1 squared, which is 1 plus k. Now plug in again x equals 1 in the equation of the tangent line, y equals 2x. So we have y equals 2x, and you will get y equals 2 times 1, which is 2. Now these two quantities are equal because the tangency point is common between the curve and the tangent line. So put them equal, you will get 1 plus k equals 2. You have 1 plus k equals 2, and solve this linear equation by moving 1 to the right hand side. You will get k equals 1. So this is the value of k that makes y equals 2x tangent line for the given curve. Part C is a big issue, so you have to pay attention because we have a lot of ideas in this part. And the question is, find the coordinates of all points in the graph of y equals 1 minus x squared at which the tangent line passes through the point 2 and 0. Firstly, y equals 1 minus x squared is a quadratic equation. And you know that the graph of negative x squared is like this. This is the graph of y equals negative x squared. But when we talk about 1 minus x squared, this means you have to shift this up. So the graph will be like this. As you will see, this is the graph of our function. This is the graph of y equals 1 minus x squared. It is shifted 1 unit up and has 2 x-intercepts, x equals to -1 and x equals to 1. And pay attention that the point you have in this question is 2, 0, and it's out of the curve. It is not on the curve. It is on the curve of the tangent line only, as mentioned in the example. So firstly, you have to know what is the point of tangency. You have to find it. So this is the point of tangency. Let's say x0 or x1, y1. Okay, and we have this point 2, 0. From the question, it is in the equation of the tangent line. So the line passes through the tangency, or the point of the tangency point, and the point 2, 0. So let's say that 2, 0 is x2, y2. Now, since the point of the tangency is common between the curve and the tangent line, so the slope from the curve at this point is the same as the slope of the tangent line. So f prime or y prime equals the definition of the slope, which is y2 minus y1 divided by x2 minus x1. y2 minus y1 divided by x2 minus x1. Y prime is negative 2x, but you have to put x1 because you want the slope or the first derivative at x equals to x1, and this is equals to y2 minus y1. y2 is 0 minus y1, so 0 minus y1 divided by x2 minus x1. x2 is 2 minus x1, and we can write it as negative 2x1 equals to negative y1 divided by 2 minus x1. But the function is y equals 1 minus x squared, so you have to plug in y1 to get 1 minus x squared. So this rational expression will be minus 2x1 equals to negative 1 minus x1 squared divided by 2 minus x1. Now enter the negative sign inside the bracket here, and you will get negative x1, 2x1 equals to x1 squared minus 1 divided by 2 minus x1. Now you have to do cross multiplication, but you have to put this divided by 1, and you will get negative 2x1 times negative x1. It will be 2x1 squared minus 4x1 equals to x1 squared minus 1 times 1, which is the same, x1 squared minus 1. Now we have a quadratic equation, and you have to solve this equation by moving all from right hand side to the left hand side, and you will get 2x1 squared minus 4x1 minus x1 squared plus 1 equal to 0. Now you have to group the similar terms to add them. So these are the similar terms. 2x1 squared minus x1 squared, which is minus 1. So we have x1 squared minus 4x1 plus 1 equal to 0. Now this quadratic equation is ready to solve. And as you know, the famous method is to find two numbers, multiply of them equals 1, and sum of them equals to -4. And there is no like these two numbers. So you have to use the general rule to solve this quadratic equation, which is x equals -b plus minus b squared minus 4ac divided by 2a. So first you have to determine what is a, what is b, and what is c. A is the coefficient of x squared, which is 1. B is the coefficient of x, which is -4, and c is 1. Now you have to apply the general rule, and you will get x equals minus b, which is minus 4, it means 4, plus minus square root of b squared, which is -4 squared. So you have to cancel negative because the power is even, and you'll get 16 minus 4ac divided by 2a, 2 multiplied by a, 2 times 1, and you'll get 4 plus minus square root of 16 minus 4, 12 divided by 2. Now, as you know, square root of 12, you have to simplify this root, and 12 equals 4 times 3. So we have square root of 4 times square root of 3, and this will give us 2 square root of 3. So we can write this as 4 plus minus 2 square root of 3 divided by 2 divided by 2, and you will get 2 plus minus square root of 3. So this we have two x coordinates for the point of tangency. So we have 2 points of tangency with the given conditions and the example. But here you have to find all points. This means you have to find x coordinate and y coordinate. And to do that, you have to plug in the values of x you get here in the curve of y to get the tangency points. So first you have to find y of 2 plus square root of 3, and this will give us 1 minus 2 plus square root of 3 squared, which is 1 minus, now you have to expand this expression, and it will be the first one squared, as you see here, which is 4 plus 2 times the first one times the second one, which is 4 square root of 3, then plus the second one squared. So square root of 3 squared, it will be 3. And what you will get, 1 minus 7 plus 4 radical 3. Now enter the negative sign with 1 here. We have 1 minus 7, which is -6, minus 4 radical 3. Now the second x coordinate you have to plug in again and the same function, and the second one is the -1 here, and we have y of 2 minus square root of 3, and this will give us 1 minus 2 minus square root of 3 squared. With the same procedure, we have 1 minus. Now expand this expression, you will get the first one squared minus 2 times the first one times the second one, and you will get minus 4 square root of 3 then plus the second one squared, which is 3. Now enter the negative sign, but before that you have to compute the inside, and you'll get 7 minus 4 radical 3, and finally you will get negative 6 plus 4 radical 3. So we have 2 points, and the points are 2 plus radical 3, comma, negative 6 minus 4 radical 3. This is the first point of tangency, and the second one is 2 minus radical 3, comma, negative 6 plus 4 radical 3. And that's it. Thank you.